welcome back to Cosmic Arc. Today we will talk about exoplanets. This video will be about how habitable exoplanets might look like and how it would work. This presentation is meant to be simple and easy to understand. If you want more information on this topic, I recommend reading books, articles, scientific studies, and watching documentaries. Remember that we have only known about exoplanets recently in the grand scheme of things, and our understanding of exoplanets is bound to change in the foreseeable future. Anyways, I hope you enjoy the video. Let's get into it. Let's make a planet from scratch. We want it to be Earth-like and habitable. Let's give it a hot iron core like Earth. We want a rocky planet as Earth is also a rocky planet. This would generate a magnetic sphere to protect the planet from its star's harmful effects. Here is the magnetic sphere as shown. Second, we add oceans. Life can't exist without water. Now we need an atmosphere like our Earth. This will enable life to evolve and flourish, and also the oceans won't evaporate away, which is good. Eventually life might evolve on the planets. Its axis can be tilted slightly to further reflect Earth's seasons. We could add a large natural satellite here, orbiting around its star, and with its axis tilted, and boom, a large natural satellite like Earth and orbiting a star similar to our Sun. Size in this is not to scale. Having this planet rotating at a random orbit is a bad idea. If it's too close to its parent star, then it will be hot and inhospitable for life. Too far, then water will freeze and thus life won't survive. We must find a sweet spot in between. The two extremes, there is a moderate zone, the habitable or Goldilocks zone, just at the correct orbit at which water is a liquid and life can flourish. Over here. Habitable or Goldilocks zone. But why does a habitable planet have to be like Earth? Why can't we make its axis perfectly straight instead of tilted? There's nothing stopping us. Why can't there's nothing stopping us from changing the atmosphere or its parent star. Look, different color, different atmosphere, straight angle, and boom, we have a different color star. Maybe different temperature, different mass, different size, different distance. There's nothing stopping us. This planet will be rated very low on the scale for Earth-like planets. Everything can be measured in between a planet such as this and a planet exactly 100% like Earth. Earth has many landscapes, and the more a planet contains landscapes like the ones we see on Earth, then to be ranked higher on an Earth-like scale. So, for example, if it has landscapes such as plains, islands, river deltas, coral reefs, lakes, rainforests, mountains, deserts, then it would be more Earth-like. Here I'm saying before we continue, we must first make it easier to understand. It's best to divide the video into many parts are shown on the top left of the screen. What is an Earth-like planet? Why habitable planets don't necessarily have to be Earth-like? Types of exoplanets, how such an exoplanet could be for humans and other forms of life. First off, we have to know what is an Earth-like planet. We must understand what feature Earth has so we can look for them. While on other planets, Earth's atmosphere composition must be considered. While looking for Earth-like planets, we should know the atmosphere. We should know composition, pressure, and color. Checking if the planet has a large satellite in proportion to its parent planet can also make it much more Earth-like. Earth is sometimes nicknamed the blue marble because of its huge amounts of water found on it. Oceans, rivers, seas, lakes, aquifers, ponds, rain, glaciers, organisms, soil, and clouds are all players in Earth's hydrocycle. A planet must have a hydrocycle like Earth to be considered Earth-like as possible. This theoretical planet must be around 6,370 kilometers in radius, like Earth's radius, to better fit Earth's features. There are many other features we can look at when ranking a planet's Earth-likeness. Plants on our planet are green because it happens to be the best color for photosynthesis. Checking if a plant has ice caps or not is also good. There are many things that can make an planet Earth-like: similar geographical features, similar features in a star system, similar biological features, similar atmospheres, has a complex hydrocycle, similar physical features, many more things associated with the Earth. But but we also must realize not all Earth-like planets are habitable in a sense. That just because they look or feel like Earth doesn't mean it is the best place for life to exist. No better example of that than Earth-like doesn't equal habitable. The Earth, while a haven for life, can also be hell for some. Many mass extinctions have happened throughout this planet's history, many of which set back life even millions of years back. If such things didn't exist, would Earth be perfect? No. Some life has to die for others to come. That's how nature works. Let's look at Earth's sinister sister Venus. While being named after the goddess of love, it isn't so lovely. A dense atmosphere and high temperatures make Venus a hellish version of our own world. It's about the same size as Earth. It has a dense atmosphere, and it's the closest planet to Earth, but it's nowhere near livable. These images were taken by the Russian spacecraft Venera 13. They show Venus's wasteland that you would expect to be after a little more research into its features on paper. Temperatures here reach such high levels that any life form, no matter how adapted, will obviously succumb to the fate of being boiled, burnt, squished, and poisoned by Earth's sinister sister. Surprisingly, this wasn't always the case. There was once a time long ago in the solar system existed where the worlds of Mars and Venus it did have water on them. While it's unknown if they did support any life during this time period, it is known that they did exchange materials from one world to the next, meaning that you could make the valid argument that some of the life we have on Earth may have Venusian or Martian ancestry. While this biological argument is debated, it really makes you think of an alternate timeline where these vast oceans never vanished. They may have or may have not supported life, but it will also be incredible. But it will still be incredible to see what we that we aren't the last remaining cosmic triplet. Of course, not all land on Earth is created equal. Vast expanses of lifeless land exist on every continent, such as deserts. Some land has the capacity to support a wide range of life forms, and none is more famous than rainforests, vast forested areas densely packed with many, many forms of life. Well, for us to see what plants could exist beyond the Earth, we have to get to know them. These are going to be the planets I'm talking about. Let's start with the first one. We have to understand what planets are first using our solar system as an example. This is the inner solar system. This section of the solar system includes the planets of Mercury, Venus, Earth, and Mars, all of which are rocky. The asteroid belt acts as a de facto border between the large gassy objects of the outer solar system and the inner smaller rocky objects. Over here we have a section of the inner solar planet, which is the solar system, which is the most inner part of the inner solar system, which contains the planets of Venus and Mercury in the hot zone of the sun. We have the middle, we have the farther point, we have the outer part of the inner solar system, which contains Mars, and we have the middle part of the inner solar system, which is Earth, contained inside of the habitable zone, while Mars is in the cold zone. This is the only planet in the habitable zone. The outer solar system contains all our gas giants. This region is dominated by the cold part of our sun's sphere of influence. It doesn't help that two planets in this region, Neptune and Uranus, are called the ice giants. The two largest planets in our system, Jupiter and Saturn, Jupiter being the largest of the two, are famous for their moons and ring systems. Beyond Neptune is the Kuiper Belt. Imagine the asteroid belt, but much more vaster and more unexplored. It contains dwarf planets such as Pluto, sorry for that, Eris, etc., plus smaller objects dotted around this region. But this region is important. What we need to know about is the 8 planets in our solar system. The first type of exoplanet is a tidally locked planet, otherwise called an eyeball planet. The unique thing about this that this planet, much like our moon, only has a single face staring at its parent. Instead of staring into another planet, it stares into its parent star. What this means is the planet is vividly divided into two zones: a hot zone that always faces the star, and a cold zone that only faces the dark, empty void of space. There is hope for this unlucky planet. A sweet spot between the two zones exists, or the conditions are not too extreme. In this artistic illustration, you can see the divide clearly. The sweet spot has water, and whenever there is water, there is a chance for life. Earth is the only place that we know of so far that houses life. So everything that happens on these exoplanets must be related to similar things on Earth because, well, we have no other options. Life is on here for certain. Here is a river valley. Rivers have historically bred life and civilization to the lands they flow in. Here is the Nile River, a river which, without it, Egypt would just be another spot in the desert. The Nile has created many civilizations life and into the middle of the desert. Let's make our place. Orange is for the hot zone, white is for the cold zone, and sandwiched in between is the sweet spot zone. Now let's raise it up. As you can see, mountains create rivers and shields them from the two extremes ever present. This allows for fertile soil to arise and for life to become arguably possible. We are going to compare this to our Earth for the second time. Our Earth is studied using the Geologic timescale, a tool used by science to categorize the history of the planet and to make it simpler to understand and comprehend it better. As you can see, most of Earth's history, it was in the Precambrian time, a huge span of time where the only organisms that thrived were simple and primitive microbes. Small microbes probably stayed close to each other and formed colonies. This allowed for a unique ecosystem to exist in the waters of young Earth. So now we know that life could exist in the water of an eyeball planet. I think that life would probably continue existing isolated in water. Even the strongest of all of them can survive the surface. What I think the first surface organisms, if they ever evolve, would be followed by the addition of oxygen into the valley because of biological activities of cyanobacteria-like organisms. With this, the first surface organisms would be small microbes and large colonies of protista algae, absorbing the sun's energy for biological functions. This would spread life not only in this fictional but river and to its banks. Here is the life being spread throughout this fictional river. With new food sources coming along, microbes and very primitive and simple invertebrates come along and take advantage of the new food sources. This creates competition, where some plants use these organisms as vessels to carry their seeds in order to spread it around the fertile banks. So, now we know life not only can exist in water, but can exist on the banks. Okay, so plants produce the food for consumers to consume, but they aren't the only one hungry for some consuming. Instead of consuming plants, they decide to start consuming the defenseless consumers. Now a food chain appears. The predators eat prey and the prey eat producers, and the cycle continues. It will be an arms race. Prey starts to become faster, more energetic, and could even evolve to hide farther away from the banks, away from the predators. Predators will also become faster and evolve to catch prey far from the banks. Producers will also start to evolve. They would create complex systems between them as a type of hive mind. And with this capacity to better spread their seeds as to not get consumed into extinction. So now the plants spread, but there is one major flaw. Life could evolve on a planet, just not to the extent of Earth. I don't think that life on this planet would be interesting. It won't evolve into the level of complexity as Earth's life. Life only has a small strip to evolve. In general, Earth has lots of locations for life could settle in. On the other hand, Earth is basically a haven for life anywhere. Well, time to look at gas giants. Not about their moons, but about themselves. I will talk about the moons later. On October 18th, 1989, a spacecraft called the Galileo spacecraft was sent on a voyage to explore the behemoth which was Jupiter, king of the planets. In its trip, it managed to collect important data, but none was more important than what its probe collected from Jupiter. The spacecraft decided to deploy a probe into the heart of Jupiter. The probe started off by going through the thick layers of the atmosphere. Eventually, the probe began to gain speed, and with more speed, gases around it started to heat up, and it looked like a shooting star. Luckily for the probe, it had a heat shield to protect it from this heat. After that eventful entry, the probe then sheds its heat shield. It deploys parachutes to slow its fall, creating an upwards force to counteract the downwards force. This probe collected lots of data, such as data on pressures, composition, wind speed, and most importantly, if Jupiter has life or not. It was hypothesized by NASA scientists that small and light microbes might exist in the clouds of Jupiter. Well, this hypothesis was quickly debunked when the probe found no signs of any light-floating microbes in Jupiter's clouds. After that, the spacecraft would also pay the last probe of it just without a heat shield. It was intentionally destroyed. The reasoning was that many moons of Jupiter may contain life. The spacecraft had some small amounts of Earth microbes on it. They were afraid that these microbes could harm the ecology of these moons if life did exist on them. Yeah, well, we have another planet which is rocky and has lots of gas. It doesn't help that Venus is short, that a Venusian year is shorter than a day there, but there might be a way for life to exist on there. High up in the clouds of Venus is some pretty Earth-like features. White clouds with a clear blue sky. This is recent news. Recommend you research it yourself because this subject could make a video of its own. Life could exist, possibly, arguably, in the high clouds of Venus because of phosphine. Well, where there's water, there is life. How about this entire planet, just that, water and nothing else? This gets us to our third exoplanet, water worlds. Here is a map of Earth. Cairo, Baghdad, Indus, China, Tokyo, Singapore, Sydney, Cape Town, Barcelona, Paris, and London, Istanbul, New York, San Francisco, and Rio de Janeiro all have something in common. They are all major human populations located on bodies of water. Water is important for humans. Even the very place where humans came from what is now modern-day Ethiopia is a region fed by countless rivers. Water is important because of trade, drinking, and of course, life. Our world is based around water. How about we have water worlds split into two general categories, icy water worlds and Earth-like water worlds, here and here. Let's start with icy water worlds. Let's look at Europa. It's a small moon of Jupiter. It doesn't have the best position. It is in a zone of constant radiation and cold temperatures, not so ideal for life. And if that isn't ideal enough, then you have to realize it has no atmosphere and no surface water. So why did I include it? Well, it's because of the fact that there is water on it, loads of it. It's just hidden under a vast layer of ice. The ice protects the water from extreme temperatures and the constant threat of radiation. Europa is a moon. It's influenced heavily by Jupiter's massive gravitational force. While orbiting its parent planet, Europa is often stretched into a slight oval-like shape and then unstretched back to its globe shape. This causes those famous cracks on the surface of Europa to form. It also heats up Europa's core, making the inner part of Europa, which would normally just be ice, into liquid water. So could we possibly explore Europa's secret ocean? Well, it is possible, but very hard to do. What I foresee is a mission that uses heated drills to chip away at the ice over a long period of time, possibly powered by nuclear energy. Once this mission finally reaches Europa's ocean, it could deploy a craft to search below the icy ceiling. Because of Jupiter's stretching, volcanic activity may occur at the seafloor. Hydrothermic vents, much like on Earth, spew nutritious minerals which could allow for organisms to thrive near it despite basically being in an ocean equivalent of a desert. Now we head off to Jupiter's ringed neighbor, Saturn, more specifically one of its moons. Enceladus. This moon of Saturn, located far out in the planet's orbit, is interesting. This moon constantly spews hot water into space, creating Earth's E-ring. Much more interesting is the fact that organic materials have been detected in this moon. While it's debatable if Enceladus could hold any true life, it could still teach us about how life could adapt to such climates. Parts of Enceladus could sustain life, as they are very warm, unlike the infamous cold of Saturn. I think it may or may not contain life. Comment down below what you think. The ocean is very, very important. It covers 71% of the Earth's surface. So let's imagine we remove all land and all that is left is water as far as the eye can see. Would this world be habitable? I think yes, because for most of life's history on Earth, it lived only in the ocean. So this is basically the same thing, just without the land. If land does exist on this planet, it wouldn't be too big. Just small dotted atolls, maybe some of them could support plant life, volcanic islands, and large sheets of ice. As I said before, there's nothing stopping life from evolving like we see on Earth's oceans. Just imagine life, but with a vast unexplored ocean. Now we get to a quote-unquote perfect world. Looking at Earth, not every place is created equal. Over here is the Sahara Desert, the largest hot desert on Earth. Very few life forms exist here. Going to the Western Hemisphere, we can see the Amazon rainforest, a densely packed collection of many forms of life. So let's have our planet be all rainforest. But I don't see this happening. The tropical regions would have massive bias, as the poles would be colder, and thus can't support life all around in every place. You can't make a perfect planet. You need a vast network of lakes, rivers, tributaries, etc., just to support a small part of this planet. This would be a nightmare to figure out how a river could be positioned in just the right positions for life to be perfect. No, at least for now, I don't see any perfect planet. Now we'll get to this one, an Earth-like planet. We know what an Earth-like planet is, but what I need to know is know if our planet is reliable in the sense that we could use it to study other habitable planets. because of our understanding of space is very new, and a lot of it is unseen. On our left, we could have lots of undiscovered worlds, and on our right, the same thing. The point I'm trying to get across is that using Earth as the scale of all life in the universe is a bit faulty. It's like taking a cup of ocean water and using this as proof that whales don't exist, because no whales are present in that cup. It's that Earth can't be the best reliable source. We can only be 100% certain about life if we find life outside of our Earth, and we can use it to compare it. About humanity's expansion into space, I think our future relies on this cosmic voyage to see what is beyond, to be a pioneer, and to explore. We might settle on such words, might just leave them, but indicate that we have been on here. We might use it for science and further our understanding of the universe. We could extract the resources for the benefit of our species. It is up for the future to